In this single breath, in the space between heartbeats, something extraordinary is happening. Right now, as you sit there, a billion particles are streaming through your body. They pass through your skin, through bone, through the very atoms that form you, and they continue on their journey as if you were not even there. They are dark matter, and to them, you are the ghost. When you look at the night sky, you see stars scattered like distant campfires in an ocean of black. But that darkness is not empty. It is not void. If you could see with different eyes that perceive gravity instead of light, you would witness something breathtaking. The darkness would bloom with presence. Halos of invisible matter, vast and serene, cradling galaxies like luminous seeds in enormous gentle hands. We live, it turns out, on the surface of things. The stars, the planets, the rocks and trees and all the matter we can touch. These make up less than 5% of what exists. The rest is hidden. Not hidden in the sense of being far away or obscured behind cosmic dust, but fundamentally invisible. The universe has kept a secret from us, written in a language our eyes cannot read. This is the story of dark matter, a contemplation on the invisible ocean beneath the waves we see. Let us begin with what drew us to this mystery. In the 1930s, an astronomer named Fritz Zwicky turned his telescope toward the Coma Cluster, a gathering of galaxies bound together in a cosmic dance. He measured how fast these galaxies were moving, swirling around each other like autumn leaves in a gentle wind. But the speeds he measured were impossible. The galaxies were moving so fast they should have torn themselves apart, scattered into the void like dandelion seeds on a storm. Unless there was something else there. Something he could not see. Something holding it all together with invisible threads of gravity. He called it dark matter. This ghost in the machine of the cosmos. But the world was not ready to listen. Decades passed. The universe turned. And in the 1970s, an astronomer named Vera Rubin looked at spiral galaxies and noticed something peculiar. Stars at the edge of galaxies, far from the bright galactic center, were orbiting just as fast as stars closer in. This should not be. In our solar system, distant planets move more slowly than inner ones, following the mathematics of gravity written by Newton and refined by Einstein. But galaxies were not following these rules. Picture a vinyl record spinning on a turntable. The outer edge moves faster than the center, but every part completes one rotation in the same time. This is what galaxies are doing. And the only explanation was that galaxies are not just the bright spirals we see. They are embedded in something larger, something that extends far beyond the visible light. Halos of dark matter, enormous and diffuse, providing the gravitational embrace that keeps galaxies whole. We are not looking at galaxies, you see. We are looking at the bright frosting on an invisible cake. The stars are just ornaments, decorative sparks scattered through the gravitational wells carved by dark matter. Without dark matter, there would be no galaxies. Without galaxies, no stars. Without stars, no planets. Without planets, no us. We exist because of something we cannot see. Now let us ask the question that echoes through every observatory and laboratory. What is this invisible presence? Dark matter is not simply matter that is dim or far away. It is not burned out stars or clouds of cold gas floating between galaxies. It is not black holes lurking in the depths. We know this because such objects would leave traces, signatures in the light that passes through or around them. Dark matter is more subtle than that. It does not emit light. It does not absorb light. It is both perfectly dark and perfectly transparent, like a ghost that casts no shadow. Imagine for a moment that particles are like people in a vast, crowded city. Some speak many languages. These are particles like electrons and quarks that interact through multiple forces. They shout to each other using electromagnetism, exchange quiet messages through the weak nuclear force, bind together through the strong force. They are social, interactive, constantly in communication. But dark matter particles, if they exist, are the quietest citizens of the cosmos. They speak only one language, gravity. They respond only to the curvature of space-time itself. They pass through normal matter like strangers passing on a street, not even making eye contact. This is why they can stream through your body, through the earth, through the sun itself, and leave no trace. This tells us something profound. If dark matter particles interact so weakly with themselves, they cannot lose energy through collisions. They cannot cool down and collapse into smaller, denser structures. This is why dark matter forms enormous, diffuse halos instead of clustering tightly like normal matter. Normal matter is gregarious. It wants to gather, to form stars and planets and people. Dark matter is solitary, content to remain spread out across vast distances. A cosmic fog that permeates everything. In the earliest moments after the Big Bang, When the universe was a seething plasma of energy and particles, dark matter particles would have been created in vast numbers. As the universe expanded and cooled, most particle-antiparticle pairs would have found each other and annihilated in flashes of energy. But dark matter, interacting so weakly, could more easily evade its antimatter counterpart, like ships passing in the night of an expanding universe. They survived. And they are still here now, 13 billion years later, the ancient relics of the universe's first movements. So, what could dark matter be? The most popular candidate has been given an almost whimsical name, the WIMP, or weakly interacting massive particle. This is not a specific particle, but a description, a profile of what dark matter might be like. Massive enough to move slowly and form structures, interacting weakly enough to remain diffuse and invisible. And there is something eerily beautiful about the mathematics here. When physicists calculate what interaction strength a particle would need to survive from the Big Bang in the right abundance to explain dark matter, the answer comes out to be roughly the strength of the weak nuclear force. This coincidence has been called the WIMP miracle. One way to get a WIMP is through supersymmetry, an elegant extension of our current understanding of particles. Supersymmetry proposes that every particle we know has a heavier partner, a shadow companion we have not yet met. The lightest of these partners, perhaps, a particle called the neutrino, could be stable, massive, and weakly interacting. A perfect dark matter candidate. It would be, in a sense, the lightest ghost from a whole family of ghosts. But supersymmetry is still just a theory. We have not found these shadow particles, despite decades of searching in the most powerful particle accelerators on Earth. The universe has not yet confirmed this elegant mathematical dream. There is another candidate, smaller and stranger, the axion. This particle emerged not from the search for dark matter, but from physicists trying to solve a different mystery entirely, a puzzle about why neutrons do not spin in electric fields the way they should. The axion would be extraordinarily light, a mere whisper of mass, less than 1% of even the nearly massless neutrino. But what axions lack in individual mass, they would make up for in numbers. If a cubic centimeter of space contained one WIMP, it would contain 10 quadrillion axions, a blizzard of invisible particles, each one barely there, but together forming the bulk of the universe's mass. Imagine standing in a snowstorm where each snowflake is invisible, weighs almost nothing, and passes through you without touching. That is what an axion snowstorm would be like. And we might be standing in one right now. There are other possibilities. Sterile neutrinos, even more ghostly than the already ghost-like neutrinos we know. Particles that interact only through gravity, not even through the weak force. Or perhaps dark matter is not one particle but many, an entire dark sector, a parallel family of particles interacting through their own dark forces, living out complex dynamics we cannot observe. There might be dark atoms, dark chemistry, perhaps even dark complexity we cannot imagine. A universe within our universe, overlapping but invisible, vastly more massive than everything we can see. The search continues, deep underground, in laboratories shielded from cosmic rays. Detectors wait in the silence for a dark matter particle to collide with an atom of xenon or germanium. In space, telescopes look for the faint signature of dark matter particles annihilating each other, perhaps producing a subtle glow at the center of galaxies. At particle accelerators, physicists smash particles together at enormous energies, hoping to create dark matter particles, and watch them disappear, leaving only the ghost of missing energy in their wake. So far, the dark sector has kept its secrets. But this is not a failure. This is the frontier. This is the edge of human knowledge, the boundary between what we know and what we wonder. And perhaps that is the deepest contemplation here. We are made of atoms, carbon, and oxygen and nitrogen, forged in the hearts of ancient stars. We are made of light, in a sense, of matter that interacts with photons, that can be seen and touched. We are the visible universe, intricate and rare, but we float in an ocean of darkness, surrounded by a presence we cannot perceive directly. We are the bright foam on the surface of a vast dark sea. This could be humbling, and it is. But it is also wondrous, because we have found this invisible ocean not by seeing it, but by thinking about it, by measuring the movements of galaxies, by calculating gravitational effects, by following the mathematics of the universe to conclusions our eyes cannot confirm. We have extended our senses beyond our senses. We have learned to see with our minds what our eyes cannot show us. And in doing so, we have discovered that we are not separate from this mystery. We are part of it. The dark matter halo of our own Milky Way galaxy extends far beyond the visible stars, far beyond our solar system. We orbit within it. It is all around us, invisible and patient. The gravitational scaffolding upon which our galaxy hangs. Every moment, every breath, dark matter particles pass through us, through our world, through our star. We are embedded in the dark sector. We always have been. Know that you are also sitting in an invisible ocean. Know that particles beyond counting are streaming through you right now. Messengers from the early universe, survivors from the first moments of the universe itself. They have been here all along. These ghosts, holding galaxies together, making structure possible, making us possible. You are not separate from the cosmos. You are not an observer looking at the universe from outside. You are a way the universe has of knowing itself, a small temporary pattern in the visible matter, briefly conscious, briefly wondering, briefly aware of both the light and the darkness. And that is enough. That is everything. The dark sector waits, patient and vast and invisible, and we continue to search, to wonder, to reach toward understanding. Not because we must, not because this is what we do. This is how we honor the mystery, by looking at the darkness and asking gently and persistently, "What are you?" And the universe, in its infinite patience, whispers back, "Keep looking."